Hello everyone, welcome back to my channel. So in today's video we are going to talk about grade 7, the 15th unit, soil. I have divided this lesson into several parts, and today in this video we are going to talk about the first part. Now without any delay, let us start off with the lesson. First and foremost, we must understand that the Earth's crust is rich with soil, and here we must understand that this soil is very important for the existence of animals, because we use this soil for agricultural activities and many more things. We use soil to grow plants, we use sand, which is also a part of soil, to build houses, glassware, and another type of sand we get clay, so that we use to make bricks, tiles, ceramics. So there are so many uses out of this soil, and we get soil in the Earth's crust. So as we get this soil all in the Earth's crust, there are many uses of the soil. Therefore, it's very much essential for our existence, for our animals and plants. Now, soil consists of different particles and textures. Therefore, soil is different from place to place. Like I had said earlier, there are different types of soils, and from place to place they have different textures and particles. So we have different types of soil in different places. Now, mineral particles in soil is divided into three groups based on their sizes. So the largest one is sand. Then we get silt. Then the third one is clay. So like you can see here in the figure, mineral particles in soil, there are three mineral particles in soil: sand, silt and clay. We have divided these mineral particles into these three categories based on their size. As you can see here, sand is very big. Sand is very big. Silt is bigger than clay, but smaller than sand. Clay is the smallest mineral particle. So based on the size, we have three groups of mineral particles in soil. The nature of those groups is described here in this table now. So when you look at sand, like I had said earlier, it's bigger than clay. Sand, it's bigger than clay. Now here you can see a small diagram of it. So sand is bigger than clay. Clay is very small, sand is big. Sand has a very hard texture. Silt, it's medium in size because it's smaller than sand but bigger than clay. It's quite soft. Then clay, it's the smallest particle, so it's very small, and that's also very soft. Now here you can see some microscopic views of sand, and then silt, and of course clay. These are really interesting. If you get a chance to observe this under a microscope at school especially, please try it out, because this is going to be something really interesting, and you all will be able to observe structures like this. Sand is very hard because it has some large particles like this. Silt and clay have even smaller particles, that's why they are considerably soft. Anyway, moving on. According to the abundance of these particles, by particles I mean sand, silt and clay, there are three types of soil. You get loamy soil, sandy soil and clayey soil. Now we will be talking about this a little bit more in depth in the next part. So let us move to that part. The first type of soil we are going to talk about is clay soil. Now clay is much more abundant in this soil. This is a type of soil, and here we get a lots of clay. Since we get a lots of clay in this soil, we call it clay soil, and its properties are very much similar to that of clay. So here you can see it's very moist, and it basically looks like clay itself. So when you consider clay, you know, okay, when you take some clay, you will notice it's very sticky, and so many more properties. It's very moist, it's very sticky. So in the same way, this clay soil is also very moist, very sticky, and clay is abundant in this. Here, as you can see, it's very moist. That means it can retain water in it, and at the same time it can retain minerals, because minerals can be dissolved in water. So if it can keep water, definitely it can keep minerals also. And the next thing what we must understand is that here retention of air is less. That means it can't store lots of air. Now, as I had said earlier, this lesson is divided into two parts. The first part, I'm going to talk about these types of soils, which is this video of course, and the next part I will be uploading soon. There we are going to talk about what comprises in soil. So in that, in soil we find air particles. So if you consider some soil particles like this, just think of these as soil particles, this red colored circular things. Inside this you are going to get air particles. These things with some weird lines, just think of them as soil particles, and these things without lines, you just think of them as air particles. So in soil we have air. This is air particles, this is soil particles. Here, because clay soil retains air very less, therefore you don't get much air in this soil. Next thing is, we must understand that it's used to make bricks, which we normally use to make houses and stuff, and tiles, especially roof tiles, like you can see these, and also ceramics out of clay. Here there are lots of beautiful ceramics. So basically this is all under clay soil that y'all should know. Next up, we are moving to sandy soil. In this soil, as the name says, sandy soil. So here sand is the mineral particle that's mainly abundant here. Particles are arranged very loosely. So if you take some sandy soil to your hand, normally you can find these near the beaches or otherwise in construction sites. When you take them to your hand, you will notice they are very smooth, sort of like they easily will, there's a very nice texture to it. So you can see that particles are arranged loosely. So that means like the air space, if this is the soil particles, if these are the soil particles, the air space, the space occupied by air, it's very much high. So these soil particles, so sand particles, are loosely held. They are loosely held. And like I had said earlier, can store lots of air in it, therefore retention of air is high. Air retention is high. Now since air is stored in it, the water retention is going to be less, because already air occupies a lots of its space. And in this soil, as you know, it's very dry, like it's not very moist. So that means there's less water anyway in this type of soil. In the previous one, water, in clay soil, water occupies most of the space. That's why it's very moist. Therefore air has not much room. Anyway, coming back to sandy soil, we use these things in building industry to make various things. Now here you can see a certain vehicle digging some sandy soil for in this construction work. And it's also used to make various glass items. Now, the process of making glassware is not a very simple process. But in a nutshell, if I had to tell you all, basically you are going to take some sand, but not any sand, sandy soil. So sand, that's the type of mineral you get here. So sand, and then you're going to mix it with some sodium carbonate, calcium carbonate, another waste recycled glass. You're going to heat it, and this is just a simple process. The process is really huge. It's not so simple as this. And then you are going to get some glass particles. So you're going to get glass. So this is the rough process where we use sand in order to produce glassware. Anyway, moving to our next type of soil, that's loamy soil. Loamy soil has sand, silt and clay in it. And over here you get a lots of organic matter. In simple, if I had to put for y'all's level, y'all can think of organic matter as when you simply decompose animal and plant waste, we get organic matter. You can simply think of it as like that. But really organic matter is a really diverse thing which you all will be learning later on. But for the moment, just remember we can get this organic matter through decomposition of, or basically through this waste matter of plants and animals. So you can do this thing. There are various ways where you can make something called a compost bin. So you can make a compost bin, or you can purchase one and put all of your remains, food and animal waste into it, and then get compost. So that's called decomposition. Plant waste and animal waste turning into compost. That is a certain type of decomposition, and there those matter you could consider to be organic matter. Anyway, water and air are retained sufficiently. That means both are balanced in this scenario. Soil is rich in soil organisms. Now here you will get lots of soil organisms, which we are going to talk about further on in the next video. And since it's rich in soil organisms, it's going to, like I said earlier, help with the decomposition of plants and animal waste and produce organic matter, which is going to make this loamy soil quite rich with it, which is going to be very useful for the growth of plants. And here we also are told that water and air is retained sufficiently. Therefore, it is used a lot for agricultural purposes, and this is the type of soil you get in pots. In pots, this is the type of soil we normally find. So anyway, that's basically it under those three types of soil. Here in this table, this is a table from your textbook, they have summarized everything that I said now. You can see the first type of soil is clayey, second type sandy, and loamy soil. Here the nature of the soil is, when you consider clayey soil, nature of soil is clay is more abundant and it's very sticky. The properties, it retains water and minerals, and also the air retention is less. It's used to make bricks, tiles and ceramics. Sandy soil, the nature is that it's rich in, its sand is basically abundant, and then particles are arranged loosely. The properties are that it retains air, very high retention of air. Retention of water is less. Here water is less, here air is less. And the uses are that it's used to build, it's very much used in building industry as well as to make glass items. Loamy soil. Loamy soil, you find it in sand, like the nature of the soil is it has sand, silt and clay in it, and organic materials are very much abundant. And for the properties, water and air retention is sufficient, and this soil this soil is very much rich with soil organisms and plant nutrients. This is the thing that's very much suitable for agriculture. So this is the basic summary of everything we discussed. Now then, coming down to our next part, we are going to talk about sieves. What is a sieve? Now, a sieve is basically an equipment used to separate different sized soil particles. A sieve is something that's used to separate different size particles in soil. So there are sieves as sets with different sizes of holes. So each sieve has its own size. Now as you can see here this sieve, the holes are big. These are so small that they are not even visible to the eye. Here they are considerably big but smaller than these. These are also very much small. And here you can see more. Big, smaller, small, and here it keeps on going so small that you can't even see how small it is to your naked eye. Anyway, that's how they set this up. The largest holes are in the topmost sieve. So like such, when you're setting this up, in this uppermost sieve, you're going to get the ones with the largest holes. And in the topmost one, we are going to find large holes. And in the bottommost one, we are going to find small holes. So in that way, we can separate the particles in this soil based on their sizes. And remember that the hole size decreases from top sieve to bottom sieve. As from top to the bottom, the hole size decreases. When you go from top to bottom, it decreases. So you simply put some soil into this uppermost sieve, then you shake it, give it a good shake, a nice thorough shake. Then you're going to shake it nicely, fast, so that the particles get separated in each sieve. So that's basically how a sieve works and what is a sieve. So remember, especially they could ask, name an equipment used to separate particles in a soil. In that case, the answer is a sieve. Or they could ask, what is a sieve? Or what is the purpose of a sieve? The purpose or what is a sieve both has the same answer. It is an equipment used to separate different sized soil particles or different sized particles in soil. Okay, so that's that. Now, before we end this first part, let us do a small question. How can you convert sandy soil into, or clay soil, anything sandy or clay, into loamy soil? How can we convert sandy soil? How can we convert sandy soil into clay? How can we convert sandy soil or clay soil, anything sandy or clay, into loamy soil? So I explained earlier that loamy soil is rich in organic materials, and I told you basically for y'all how to remember what are organic materials. I told y'all that for organic materials, whenever they say organic materials, you all just think decomposed animal or plant waste. Okay, so decomposed means basically decayed plant, animals and plant waste. So how are you going to get this? We can use a compost bin and fill these things with those wastes of animals and plants and keep it for a while put all the other necessary things and get compost, which you can then use as compost. And if you mix this sandy or clay soil with this compost and stuff while these things are decaying, then you will get loamy soil. So basically, if we add suitable amounts of organic material to sandy or clayey soil, we can get loamy soil. Okay. With that, we have successfully completed part 1. So hope everyone understood the lesson. And if you all did, don't forget to like my video, subscribe to my channel and share this with your friends. Get ready for part 2. I will be uploading it soon. And if you all have any questions, don't hesitate to leave a comment in the comment section below. And if you all want any lessons to be covered by me, please leave it in the comment section and I will respond. And subscribe and stay tuned to my channel so that when I upload that relevant lesson, you will be there and you will be one of the first to receive that lessons. So until next time, bye.